Would you imagine the world without color? If you wonder how it is that we see color, it's because of light. My name is Miranda, and I'm an artist. That's why it's crucial for me to understand why do we see color and how do we see it? We see the visible spectrum every day, but maybe we don't realize it because it's just light or visible light. But what is the visible spectrum? The visible spectrum is the portion of the electromagnetic spectrum that is visible to the human eye. And the electromagnetic spectrum is the range of frequencies or wavelengths over which electromagnetic radiation extends. But first of all, what is a wave? A wave is a disturbance that transfers energy through matter or space. So, how does waves relate with colors? Electromagnetic waves are waves that are capable of traveling through a vacuum. They exist with an enormous range of frequencies shown through the electromagnetic spectrum. Although electromagnetic waves exist in a vast range of wavelengths, our eyes are sensitive to only a very narrow band. Since this narrow band of wavelengths is the means by which humans see, we refer to it as visible light spectrum. By the term light, we are referring to a type of electromagnetic wave that simulates the retina of our eyes. The visible light region consists of a spectrum of wavelengths that range from approximately 700 nanometers to approximately 400 nanometers, which is the unit in which wavelength is measured. Wavelength is the distance between the crests of a wave. Wavelength is expressed with the Greek letter lambda. It is equal to the velocity of the wave divided by its frequency and expressed in units of meters. Newton was the first to understand the rainbow. For this, he refracted white light with a prism, resolving it into its component colors: red, orange, yellow, green, blue, and violet. Then, he proved that the prism was not coloring the light by refracting the light back together. His most useful idea for artists was his arrangement of colors around the circumference of a circle, which allowed the painters to arrange primary colors opposite to their complementary colors. For my experiment, I reflected a flashlight through the prism. As you can see, the color spectrum was reflected in the wall, but it wasn't as intense. Subtractive color mixing is creating a new color by the removal of wavelengths from a light with a broad spectrum of wavelengths. It occurs only when we mix pigmented material, for example, paints. It is called subtractive mixing because when the paints mix, wavelengths are deleted from what we see, because each paint will absorb some wavelengths that the other paint reflects, thus leaving us with a lesser number of wavelengths. This means that technically speaking, black is not actually a color, but the absence of wavelength of the visible light spectrum. Finally, we are able to see color because of light. This applies to physics because it is a result of electromagnetic wave behaviors and properties. Each color is defined by a specific wavelength. There are many scientific explanations behind most of the shades of colors. For example, the additive and subtractive colors, as on the experiment performed before. The electromagnetic spectrum is incredibly wide. Imagine that the visible spectrum for humans only forms part of less than 1% of the electromagnetic spectrum, which stands between the ultraviolet and infrared rays. On the artistic world, color spectrum discoveries have been the base of many artistic theories. For example, the color wheel was a result of Newton's experiment, which led to the rules of primary, secondary, and tertiary colors. Hopefully, based on the previous explanations and demonstrations, you have a clear idea of why and how is it that we see the world in color.